There are three types of probability we're studying in this course. There's classical probability, empirical probability, or subjective probability. In each case, we're going to determine which probability is being used to describe the situation. According to a company's records, the probability that a washing machine will need repairs during a 6-year period is 0.10. Because this is based on records that have been kept, basically an experiment, this is considered empirical probability, also referred to as experimental probability. The probability of choosing 6 numbers from 1 to 40 that match the 6 numbers drawn by the state lottery is 1 in 3,838,380. This is based on classical probability. An experiment was not performed. This is simply calculated by the number of possible outcomes. An analyst feels that a certain stock probability of decreasing is over the next week is 0.75. This is based on his feeling. Hopefully it has some basis in his experience, but either way, this would be based on subjective probability. According to a survey, the probability that a voting age citizen chosen at random is in favor of a skateboarding ban is about 0.63. Again, being this is based on past data, this would be empirical probability. The probability that a randomly selected number from 1 to 100 is divisible by 6 is 0.16. Again, this is based on the number of possible outcomes, and this would be considered classical probability, often called theoretical probability. You think that a football team's probability of winning its next game is about 0.80? Again, this would be subjective probability. It's based on someone's feelings. Let's move down to security codes. The access code for a garage door consists of 3 digits. Each digit can be any number from 0 through 9, and each digit can be repeated. To determine the number of possible access codes, we're going to use the counting principle. There are 3 numbers that are being used here, 3 place values. We have a 10 in the first one, a 10 in the second one, and a 10 in the third one. For this reason, we would have 10 times 10 times 10, which would give us 1,000 possibilities. Now, if we were to randomly guess to come up with the correct access code on the first guess, that would be 1 out of 1,000. I'm sorry, drawing with a mouse never quite comes out very clean. What is the probability of not selecting the correct access code? Well, we know that the probability, along with the complement of the probability, should be equal to 1 or 100%. Because in this case, 1 out of 1,000 represents the chance of selecting the correct access code, then there's 999 wrong choices you can make out of 1,000. Obviously, it's much more difficult to get the correct access code than the incorrect access code when you're trying to figure out your code to get into your garage. Obviously, this is done for security purposes.